This is part 9 of reading wastewater data and part 2 of looking at wastewater collection methodologies. Here we're going to look at solid versus liquid wastewater collection. So of note, raw wastewater consists of small particles or solids that are suspended in liquid. And some studies have reported higher concentrations of COVID in the solid waste than in the liquid waste. And this study did find that COVID concentrations were higher in settled solids than in the influent section by approximately 3 orders of magnitude. And that using settled solids in the analysis of COVID, and that the advantage of using settled solids in the analysis of COVID concentrations is that you require less sample volume to achieve similar sensitivities to that of influent methods. In this study, they looked at 5 different treatment plants, with one of them being Oceanside Water Pollution Center in San Francisco, California, where all the samples were 24-hour composites, where the solid samples were taken from the primary clarifier at each treatment facility. Of note, some treatment facilities add chemicals to their waste streams upstream of sample collection for odor control and improved treatment efficacy, and that the residence time that waste is allowed to sit in that primary chamber is somewhere between 1 and 6 hours, which brings 2 questions immediately to mind. The first being, what impact do these upstream chemicals play on the COVID concentration levels? For instance, does the addition of these chemicals upstream in some of the treatment plants cause a reduction in the overall COVID concentration in those treatment plants? And second, what does this rate of primary tank changeover play in the COVID concentration level? Because ones that aren't allowed to settle as long, so if it's 1 hour of settling time in the primary chamber versus 6 hours of settling time, you're theoretically going to have a much higher concentration in the longer settling time in that primary chamber. The partial answer to the first question is that in this study we don't see evidence that additional chemicals in the treatment facilities had an impact on sample analysis. However, they would need more replications of this study to see what impact this has, so it would need a more focused study. So ultimately they don't know what impact it has. And the sampling frequency of each of these counties, the Oceanside being the OS, varied between each of them. It was about 3 a week or 2 times a week to once a week. Oceanside fluctuated a bunch between 1 time a week to 7 times a week. So moving on, for sample collection, solid samples were collected by a treatment staff from the sludge line, which did not target a specific layer of the sludge. They just stuck a syringe in and pulled waste out. And then these collected samples were immediately stored at negative 80 degrees Celsius until analysis, the exception being Oceanside solids and AA solids, Ann Arbor solids, which were stored at refrigeration temperature and analyzed within 6 hours or 1 week. And then for Oceanside, they were shipped or driven to the lab on ice on the day of collection to be processed within 3 days. And interestingly, Oceanside decided to use a 2-sided Grubbs test to identify outliers, and this is a test where you identify outliers and then you remove the outliers from your samples, from your sample statistics. So for instance, if most of the data was concentrating over here and then some of the samples were out here, they would identify those, remove those from the data set, and then just focus on these. So for wastewater facility treatments, I don't think this is an appropriate way to use this test. I think all data should be reported, but that's one of the things that they do at this treatment facility. Additionally, the PMMOV virus that they use as a calibration is much lower in Oceanside wastewater facility than in other wastewater facility treatment plants. So when they try to do a correction based off of a standard, this could be correcting it to a lower value than it should be. So skipping to the results, COVID is enriched in the solid fraction of wastewater by 3 to 4 orders of magnitude on a mass equivalent basis, meaning that the settled waste in the tank is going to have a much richer density of COVID than you would get by just pulling out the supernatant liquid, the free-floating liquid in the waste solution. And really interestingly, most of the COVID concentration is from free-floating suspended particles in the solution, for when they're looking at the liquid phase influent, which implies that that turnover rate from the primary clarifier is really important. So if it's changing over every 1 hour, you would have a higher rate of turnover within the system, so there would be more free-floating particles in the system than if it's taking 6 hours to do a clearance of that tank and to move it on along the process. Because this new inflowing mixing that's occurring, so you're mixing and you're pushing out and you're mixing and you're pushing out, The higher that rate is, the more particles you're going to have, which means the higher the COVID concentration is going to be in that liquid phase that you're sampling. So these are all things that you're going to want to consider when you're looking at wastewater concentration and how it could be influenced by the methods used.